Well, hello, everyone. Good evening. I hope dinner's going well. Hope you're enjoying the cheesecakes and all the other stuff that's out there. I want to just briefly introduce the speakers for the dinner program tonight. It was a really, I think, a great segue to have the Newman Grove students present at the end of the afternoon. And we sort of transition into our dinner program, and we talk with and hear from more students in the Northeast Nebraska area. And I think the grades are 9 through 12. Wow, okay, we have some students tonight who are in 7th grade, so really cool to hear from this kind of a range. So I should tell you who they are. We have with us 2 teachers from Madison High School, Susie Foley and Patrick Cradaville, who I asked to phonetically spell his last name for me. Thank you. They're both science educators at Madison High School, and they also coordinate the school's Watershed Dynamics group. So they're involved in groundwater, heavily involved in surface water as well. I did want to recognize just quickly Brian Bruckner with the Lower Elkhorn NRD, who helped connect us really to this group, and I think that's great to have them tonight. So thank you for that, Brian. And we also have Christopher Olsen, who is a current graduate student at the School of Natural Resources at UNL, and he has interacted for a couple of years now with Patrick and Susie and the students at Madison. And he is really kind of the trailblazer and the engine behind our Know Your Well science education project. And he's going to talk a little bit about that this evening. So I think with that, I'm going to cue a quick video that gives an overview about Know Your Well, and then Christopher will take it from there.
What's in the water you're drinking? How do you know the quality of your drinking water? The majority of Nebraskans get their drinking water from groundwater. But what's the quality of drinking water that comes from the groundwater near you? Know Your Well is a hands-on interactive project for high schools in Nebraska. You'll be able to research the wells in your area and reach out to the owners to ask about the history of the well and the quality of its water. Then you'll go out into the field to the wells to collect water samples and survey the well and land around it. Afterwards, you and your group will test the samples for different possible contaminants at your school with testing kits. You'll also be able to use social media to help raise awareness of well testing to earn prizes. You may also have the chance to present findings at conferences to a wider audience. In addition, working with this project allows you the opportunity to earn scholarship money for college. Know Your Well is a great way for you to know more about the groundwater in your community and your state.
Can you hear me wave? Okay, good. All right. I'll try not to speak away from the mic. So also to the speakers later after me, this is an appropriate way so that everybody can hear you, right? Okay. So that I know that everybody is paying attention as I do this practice with high school students across Nebraska, a call and response, and to test the hospitality of Nebraska. Good evening, everybody. Good evening. All right, very well. Okay, my name is Christopher Olsen. I am a graduate student in University of Nebraska. I am very humbled and grateful to be part and assist in this project, Know Your Well. Water is something that can break boundaries and barriers. Everybody can relate with, especially in the physical realm. Everybody needs air, water, and food, right? Water is one of those three that keeps us alive. So regardless, everybody can relate to water directly or indirectly. So water is not just for a specific few. Water is, and let me be clear, for everybody, all right? So regardless of your economic background, your political background, your religious background, water is for everybody. So with that in mind, water quality is very important. Nebraska definitely depends on groundwater. 20% of Nebraskans get their groundwater, their drinking water from groundwater, from private domestic wells. These private domestic wells, there's no incentives politically or economically to get them tested. So oftentimes, wells are drilled, and that's about it. Water gets pumped up, and people will start drinking it. There's no testing to see how good the water quality is of the water that is being pumped up into the house. So, Know Your Well is a project to get people informed about their drinking water in rural Nebraska. So we go around to participating high schools. Here's the 19 high schools that are currently participating in this segment of Know Your Well. It is expanding. And so we had two schools here with us tonight. One of them is going to speak right after I get done with this. I need to be really quick so the spotlight can be on them and not on me. My research is on citizen science, and I know that's been brought up in the previous presentation, but I'm not sure it was defined. And I know that a lot of you understand what citizen science is, but to those of you who do not, it's a case of a limitation of the quantity of professional scientists trying to do research where they can only be in one place at one time. Whereas if they get to train and work with the general public to train them and educate them on the most basics of data collection and sample collection, that means there's a whole lot more that can be collected and gathered. So multiple places at same and multiple times instead of relying on a limited amount of professional scientists. And then in that case, also Sarah Brock mentioned up in the previous speech that she was speaking segment earlier, she mentioned that reporting is very important. So the high school students report their results, and in turn, the professional scientists, in this case, the Water Science Laboratory, reports their results to the high schools, and there's dialogue created. So one part that I skipped is that what actually happens is the high school students go around to people who would like to have their wells tested. They take enough quantity of water sample for the high school students to test, as well as enough to be sent to the Water Sciences Laboratory to be tested under professional scientists. So then there's a way to compare and try to validate citizen science, which is a hot topic right now. So to segue into Madison High School, they've been working with surface water as well as groundwater quality. So enough time of me taking up their spotlight, and I'll pass it off to you guys.
Welcome to our Taylor Union Watershed presentation. We want to thank you all for listening to our presentation of 2019 to 2020. Our advisors are Susie Foley, Patrick Crotterville. Researchers are Kobe Johnson, Elizabeth Garcia, Kendry, Albie Rodriguez, Janae Wagner, Andrea Sotelo, Janaea Milan, Chloe Evelyn, and Dakota Golickson.
So these are our sites around Madison. Site 1, 2, and 3 are on the Union. Site 4 and 5 are on Taylor, and Site 6, 7, and 8 are both of them combined. This is Site 1 on the Union, 6 miles west and 1 mile south of Madison. This is Site 2, which is also on the Union, 1 mile west and 4 miles south of Madison. This is Site 3 on the Union, half a mile west, 2 miles south, and half a mile east of Madison. Site 4, which is on Taylor, half a mile west and 1.5 miles north of Madison. Site 5, which is on the Taylor Golf Course Bridge, which is in Madison. Site 6 is both Taylor and Union and 1.5 miles east of Madison. Site 7 is both Taylor and Union combined, 3 miles east and half a mile south of Madison. Site 8 is both Taylor and the Union, 3.5 miles east of Madison.
When testing our sites, we are primarily looking for the water quality. A good tool when looking for water quality is the water quality index. The water quality index is a series of 9 tests: dissolved oxygen, fecal coliform, pH, biological oxygen demand, temperature, total phosphate, nitrates, turbidity, and total solids. When we find our water quality is used using this Q value chart. When this specific chart is for pH. So when we get our reading from our individual tests, in this case pH, we will find that number, say 7 on the bottom, and track it up to where it meets the curve, and which is around 90, upper 80s, 90, and this gives us our Q value. We then take our Q value and plug it into this water quality index form. This water quality index prioritizes certain tests over other, dependent on its weighting factor. Dissolved oxygen with the highest weighting factor is the most important test, while total solids with the least weighting factor is the least important test. After multiplying the Q value by the weighting factor and adding up the totals, we can determine the water quality. Most of our water quality lies between medium and bad, with a few goods.
Rainfall, we take 5 days before testing, so we take it almost our days. And in May, we had a lot of rain, which kind of tampered with our other tests.
Our dissolved oxygen test is a test that we run to measure the amount of oxygen that is in the creek water that living animal life will use. Now, this test does not have any cautionary lines, and it is measured in percentage. And we want our tests as close to 100% as we possibly can, and we do have a consistency going around the 80 to 100 and a little over. Now, you can see that site 2 and 3, those are union sites, are a little lower. There's like sort of a trend going down. But otherwise, we stay consistent to the 100%.
All right, so flow is another test that we actually do at the site. What we need for this is a lab quest that we use a propeller that's with a stick, which we call a flow stick, and we face that upstream while that's connected with the lab quest, sorry, and it gives us a number basically of how fast the water is going. So as you can see on our chart on site 1 and site 2, we had a few difficulties getting into the water, as well with the months of June and July. We had different factors going into that. Some of them was the water being too high and stuff like that, etc.
Our fecal coliform test is basically how much bacteria is within the water. We use Hatcham Blue 24 for testing. Our E. coli is represented in blue, and other coliforms are represented in red. Our cautionary line for E. coli coliform is 200, and 200 colonies per 100 milliliters, which is basically our skin contact, and for that and below. At 1 colonies at 100 milliliters, which is our drinking water. May is our highest. Our total coliform is basically our E. coli plus our other coliform together. Site 3 is our highest with the results we have, and that kind of goes the same with May. And I say kind of because in July for our other coliforms, it was too numerous to count.
pH is the acidity in the water. The range is from 6.5 to 9, and our results are normally good.
5-day biological oxygen demand is a test used to determine how much oxygen is being used by the organisms in the water, the microorganisms specifically. We do this test by taking a sample of water and finding the dissolved oxygen of that sample. We then place this sample in a dark jar in a dark room. We do this to prevent photosynthesis from occurring. At the end of the 5 days, we take the dissolved oxygen again to determine how much oxygen the organisms demanded. We usually want this number as close to 0 as possible. This graph kind of skews it because it's such a small scale that the numbers look far apart. However, our biological oxygen demand was pretty good for the most part.
So for temperature, we take 2 temperatures for every site. We take 1 temperature 1 mile upstream, and then another temperature at the site where we do all of our other testing. As the sites increase, the temperature should increase, and we take the site minus the upstream site, and we take that and we measure all our tests in Celsius.
Our phosphate test, first off, does have a cautionary line, and it's at 0.5 parts per million. Now, this cautionary line signifies what we want to be under. As you can see, our tests are more above the line, and with our test being above the line, this could cause eutrophication, which is an excess amount of nutrients such as phosphate and another nitrates, which we'll get to, which leads to algae bloom, and that could cover the creek with algae and trap in oxygen inside. But otherwise, our tests stay consistent to sort of a trend, with site 4 and 5 being lower and those are the Taylor sites, with them being lower. More of the phosphate is coming from the Union sites, 1, 2, and 3, and where they converge. And we do have the sort of zigzag outlier August going up and down and being very high at the end due to Site 8. Site 8 is a site that a lot of the tests do run a tad high above the trend. Nitrates, like phosphates, has a cautionary line, but this time at 10 parts per million, and that is at the drinking water. Now, again, we do want our tests underneath, and as you can see, where the sites converge, it is the lowest. Now, our union is the one bringing in all the nitrates as well, and sort of a trend going down as we go farther through the streams. Our nitrites is another form of nitrogen, does not have a cautionary line at this point, but we do want it as close to zero as possible. May was a great month for this. We had almost zero all the time, and there still is that trend of going down throughout the sites, except for June. June was an off month.
All right, so turbidity is a test that we actually do not run at the site, and we get water samples from the creeks, and we bring it back to our lab, which is our school, and basically we compare it between distilled water and the creek water. So we want the numbers to be lower because turbidity is the clarity of the water. There's a couple, as you can see in May, it tends to get a little higher with some outliers, and we are pointing that due to the flooding.
Total solids, we take a sample from the creek and we boil off the water to it's all evaporated or boiled off. And in May, the numbers were higher because there was a flood and kind of put stuff in the water.
So ammonia is yet another form of nitrogen. For this test, our cautionary line is at 0.2 parts per million. Our tests seem to be all over the place with only a few below that cautionary line, although the graph is kind of skewed because our highest test only goes up to 1.8. August seems to be our highest month, but it also seems to be vary, so we can either have the most or the least, so kind of just varies for that month. And conductivity basically measures the water's ability to conduct electricity. So a higher conductivity value usually will indicate that there are more chemicals inside of the water of the creek. So if you can see the tests are pretty consistent. If they follow the same trend, even for August, as it is, the numbers are way lower, but you can also see that the trend still follows from the other months.
This is our WQI overall. These are the Q values multiplied by the weighting factors and added together. As stated before, most of our tests lie in the medium range. We did have a good this year and no bads, so that's a good sign.
So our chemical test conclusions for this year is that we had a lot of rain in May. Most of the phosphate and nitrate values were above the cautionary line. Site 4, for many years in the running, is our best site yet again. We couldn't choose a worse site. It was a three-way tie between Site 2, 7, and 8. So for flow, for the months of June and July, we didn't have any results for flow due to many reasons. Sometimes we couldn't get in the creek. Water level was kind of high, so we just kind of decided not to risk it. We also did chlorine and calcium tests that were not shown due to time constraints and to the fact that they are not part of the WQI, so they are not affecting our tests. We just kind of do that to just see.
On the top left, you can see researchers going down to get to the creek. On the top right, you can see them in the water getting tests to take back to the lab. On the bottom left, you see us trying to get in the water because of how deep our boots go in the mud, because of how wet it is. And on the bottom right, you see us struggling getting out of the water. On the top left, you can see the researchers getting data that we tell them from in the lake. On the top, on the right, you can see them in the water getting their tests. On the bottom left, you can see them going down through tall grass.
So Christopher already kind of talked about the Know Your Well project, but it's a project aimed to train high school students on how to test well water. Wells are tested for nitrite, metals, pesticide, and coliform bacteria. And we also compare our results that we find with the results from the lab down at UNL. This is our comparison between our surface water, which is from our watershed, and then the groundwater we find from our Know Your Well project. This graph is showing the average numbers from all of our readings for nitrites from our watershed group. And we tested 12 wells and averaged the nitrate number we got from those wells. The surface water is significantly higher than the groundwater, almost by 2 times or over 2 times. And then the same thing goes for ammonia, which we also did a comparison with. You can see our surface water is definitely has more ammonia than our groundwater. Here are a few pictures from the Know Your Well project when they came. Some of them were out testing the wells on the locations, and then the bottom left, we are doing lab work back at our school. Here's some more pictures of lab work and gathering our samples. This is from the Know Your Well project's website. They posted us, so we thought we'd share it with you guys. You can find this at knowyourwell.unl.edu.
We wanted to thank Lower Elkhorn Natural Resources District, Madison Public Schools, Nebraska Water Center, and Christopher Olsen. And thank you all for giving us this opportunity to have this program. It's an amazing program, and we learn a lot of new things. Do you guys have any questions?
Somebody,
we can't answer that.
somebody, come on.
To collect data for fun and to show the data. Not that way.
I just do it because it gives me quite a lot of experience, especially for when I head into college and stuff like that. It'll give me experience of being in a lab and consistently doing lab work and striving to get my best results. So. Yes, ma'am. Chris?
So, yeah, every school is different. Also, every sample is also different. I just came back from Crawford and also Harrisburg. Who knows where Harrisburg, Nebraska is? Or Harrison, sorry. You know where those? Okay, so they're also in it, and I just returned them their results from the laboratory at UNL, and they looked particularly for one sample they took, and then they started laughing when they saw the results for nitrate, and I asked them, why were you laughing? They said because the laboratory got a result of 23. I said, well, how was that funny? They said because when we were testing it, 23 seemed really high, and we thought we screwed up completely. So they got 23 as a high school, as well as the water science laboratory got 23. It's not always that case, but there are scenarios where they're way off, and sometimes when they're dead on. And that's what my research is on, actually.
So, first off, you guys
I think anytime we have like big outliers, especially that month of August, is it nitrates? Well, no, nitrates or nitrites, can't remember right now. But we kind of look at it and then second guess ourselves, probably run the test a couple more times and then just see what we get. But nothing really surprised me that much. It's kind of consistent from year to year. So
We have been increasing water quality since we began our watershed in 2011, was it? Yep. So yeah, the water quality of the entire creek, Union and Taylor, have been increasing in, well, not increasing in the amount of stuff, isn't it, but in the total health of it, as in it's been getting better.
Yeah. And I would say I was very surprised by having medium to good results, especially with everything that we had coming through Madison. I mean, I'm like, these numbers have to be bad. But as we were punching them in, that's what surprised me the most this year.
Well, we do give the kids credits for this for 2 summers, as long as they're there about 75% of the time. They get 5 credits of high school science. So there are some credits that are part of that. So they do get a little bit of an incentive to do that. One of the things that to add on to the kind of the water part of it is, I'm not too sure it's gotten better as much as maybe we've gotten better at doing the tests. When we started this 8 years ago, whatever it was, we were consistently pretty bad on the test results always came back as bad to medium, very little medium. And so I'm not sure it's the water that's gotten better as much as it is maybe the students have gotten better at doing this. And yeah, the science is getting better. And what's kind of unique is we've had some kids that you would not ever think would ever get in a creek in mud. We've had some fine arts students that I never would have thought, and she had a blast in this. And her highest test score on the ACT was science. So that part of what, and they probably don't understand this yet, but as we've done this a number of years, the kids that are in this program consistently have a little higher ACT science scores across the board. It's kind of amazing, because what they do right here is what the ACT is testing, only it's on the reverse side. They create the graphs and understand what's behind the graph. And in ACT, you got to read the graph, and most of you know that. You have to interpret it. So they get a little bit better look at it from the back side of that.
Yes, sir. Yeah, so we do annual presentations every year to our NRD, and then a number of years has also done presentations to the community. We didn't do one last year, but we have done so in the years before, where we invite the community over to the school and we give the same presentation that we give to the NRD, we give to the community, and we kind of try to explain it to them what the results mean. So, and then we also did a presentation at the water conference at the water center at UNL a couple years ago, where we also basically did the same presentation. Does that answer your question? Did we have fun? I have fun. I don't know if you guys have fun.
I like taking naps on it, just going back and forth. That's always fun.
There's a couple times I had to help some of the younger ones get out of the mud. That's never fun. And then you get stuck yourself. It's just a giant mess. And then you fall in the white water with the lab quest. I don't know.
Who was saying I haven't fallen in yet?
We have an age range up here from 7th, as you said before, from 7th grade to 9th grade.
Basically, we have 11th grade. The older ones are all 11th grade, the younger ones are 7th grade. Yeah. Normally we have a much bigger spread.
Yes, ma'am. The hardest thing. Probably waking up in the morning in the summertime, you know? I think that is the hardest part.
Yeah. We as the teachers ask the kids the night before, are you going to be there? Or the week before, are you going to be there? Yeah, we'll be there. Yeah, we'll be there. It's 10 to 8 and we're like, nobody's showing up. So we just never know.
We have gone to using donuts as an incentive, by the way.
But to answer your question on a real basis, I had a hard time struggling with being, I don't know, lab adequate. I don't know how you would want the word for it, but just making sure that all your equipment's clean and all that because of contamination. And I think like my first year, I definitely struggled with that, but now I've gotten better using gloves, washing out every test tube with distilled water, and all that. That was probably the hardest for me.
And to add to Colby's point, our lab work is kind of it's unique because we have mud all over the equipment, so it's kind of hard to keep it clean. So at the end of the year, we definitely do a whole big day where all we do is clean. So. Any more questions?
Oh, I wanted to say that you actually do really learn a lot of things interesting. So like one day in class, she was talking about all this stuff, digestive system and everything. And I'm like, I think I know something about that. It's part of our watershed. And she's like, okay, tell us. And I explained how fecal coliform, how they do it, how they test it. And she thought that was really interesting. But she's like, not what I was looking for, but yes, I understand what you're trying to say.